We are taking software quality assurance under software engineering question and answer. What is the life cycle of a quality assurance process? So you see here, every process in quality assurance is all about putting standards and making it followed in your organization. So here we follow PDCA. So it involves Plan, Do, Check, Act. Plan, Do, Check, Act. So this is a cycle often also known as Deming cycle. So what are the phases? The plan. So the organization as a whole should plan and develop the objective, the process related objectives. Also the standards as well as the methods necessary to provide a high quality final product. So the quality assurance ensures that the planning made takes into consideration the good quality, high quality of the product. Okay. So the quality assurance is an organization level concept. We need to plan. Okay. Next thing is to do. So now this phase involves process development and testing, as well as doing changes to the processes. So here the quality assurance ensures that the processes followed during the development, it also maintains the quality of the product which has been laid down in quality assurance standards. Then we do the check. In this phase, the processes which are being standardized, these needs to be monitored, modified and checked. Why they are to be checked? Because we need to see whether they achieve the intended goal of quality assurance. Therefore, the quality assurance ensures that the processes are checked thoroughly so that no defects might be missed. Finally, the act. Okay. Plan, do, check and act. Here, quality assurance or quality assurance tester should take the step in order to improve the process. Whatever are the steps to improve the process, this is the task here in order to act. Now these stages basically they are guaranteeing that the organization procedures, the processes which are followed in the organization, they are properly assessed and they are also improved in a regular basis. You might have heard about CMMI, you might have heard about ISO 9126, the ISO 9000s. Differentiate between quality assurance and testing. So we'll see one by one. Quality assurance, under this quality control comes, under this testing comes. So quality assurance, this can be started at the project inception phase. So it is a part, you can say a subset of a software development life cycle. So better you start from start, it will be giving you a better quality. See, the testing is the part of quality control which comes under quality assurance. So it is a subset of quality control. So when we control the quality, the main thing is to test. So quality, in order to achieve quality control, we do the testing that corresponds to quality assurance implementation. So quality assurance is a process oriented. It is because we are trying to make the processes to follow the standards, and the testing is all about product. We are testing the product, the reviewing, inspecting the product. So it is product oriented. Testing is product oriented. Also the quality control is also product oriented. So we do all the kind of testing in software. We do black box, white box. Quality assurance is preventive in nature. Why? Because we say that these process has to be followed. So it is a preventive in nature. It tries to prevent defects from being present in the product. Testing is a corrective kind of a technique. So now, if defect is there in a developed product, we try to find out and we need to remove it. Quality assurance is done to prevent defects in the product. Testing is done to find and then remove or fix the defects in the product, because testing is followed by debugging, which is removing the error or the bugs. Quality assurance ensures that the processes and the procedures followed by the team are in place, which are being set in the quality assurance or quality plan. This is what you have to do. These processes have to be followed. So this quality assurance is when you can assure your stakeholders, oh, this is a quality product. While in testing, it confirms that the product conforms to the specification being required. The user's expectation are fulfilled here. In quality assurance, the focus is on the processes that operate on the product. In testing, we have talked about it is for end product. Quality assurance is proactive. That is, the proactive strategy focus on preventing problems from even arising. While testing is a reactive process, the problem is there, now we need to mitigate it. Quality assurance need to be implemented by the whole team because it is an organizational concept. In testing, a module or a combination of module or a product, everything, the testing can be done at these levels. So testing team is more to be concerned, the software team or the product team which has made this product. This testing team is mainly the key. Differentiate between test plan and test strategy. The one-liner answer is test plan is the implementation of test strategy. So test strategy is a bigger set. Test plan comes under it. In order to implement or execute the test strategy, we do the test planning. Okay. Test strategy are the set of rules that describe how to develop test and outlines how they should be carried out. That is the bigger abstraction level. So these are the guidelines, rules for a whole organization or maybe a big project. From inception to deployment, we have a common test strategy. This has to be done. The test plan, a software project test plan, it is a document. And it specifies what? It specified the intricacies. Even the scope, purpose and approach is there. But more emphasis is on the software testing actual process. In test strategy, we have following components. Objective. What is the objective? What is the scope? How will be the document formats? These are the formats you have to follow. What are the test methodologies? What you have to do? Black box, white box, smoke or sanity or whichever. Then the team reporting structure. Who is going to test? What is the quality assurance, quality control, the structure, client communication strategy. In the test plan, we have a document or a series of documents where we have a test plan ID because you are making a test case in test plan basically. So test plan ID, feature to be tested, the test procedures, the testing task, features, pass or fail criteria, the test deliverables, responsibilities, who will do what, the schedule, the timeline, etc. So test strategy is a general approach. Here general approaches are described in the test strategy. Here test plan is more specified. The specification of testing processes are described in the test plan and that is executed, that is implemented by the test cases. Finally, test cases are written. Now, the testing manager. So we are talking about test plan and test strategy. So test strategy, the project manager implements a test strategy, or you can say that the managerial level person do this. So it specifies which approach to use and which module to be tested. They can also prioritize it. While in the test plan, a testing manager or the lead executes a test plan that specifies how to test, when to test, who is going to test, and what to test. So here the level of abstraction is more detailed in test plan. In test strategy, it is impossible, very difficult to alter the test strategy because it is being created for the whole project or the organization. Test plan, the changes can be done. Okay, changes because if test cases are there, one test case is not good, you can remove it, you can add more test cases. So test strategy is a long-term approach. You can use information that isn't specific to a project to create a test strategy, because this is a broad view for different projects. Test planning is done to identify risk by determining potential issues and dependency, because here the test planning is done like that. Test cases are written like that. Okay, this may affect this one like this. Test strategy is frequently found as an element of a test plan in smaller projects. So in a smaller project, test strategy and test plan can be together. But test plan is individual. It can exist individually. In the test planning, it is established at a project level. That is, the test strategy is at the organization level, and it can be utilized for different kind of projects. That is why I am saying it is at the top level of abstraction. Explain the types of documents in software quality assurance. So software quality assurance is at organization level. It is all about processes to be followed, standards, rules, we can say. So these are the documents in the software quality assurance. The first one is SRS, software requirement specification. All the functionalities, all the requirements are to be added in the application. These are documented in the SRS or the requirements, and the document is known as software requirement specification. This requirement document is made in the collaboration with the stakeholders and the software team. There can be other people also involved, but they are properly signed by the two parties. Then we have the test metric. These are the quantitative measure. So testing the psychometric complexities and all these, this in order to determine the quality and the effectiveness of the testing process. There is metrics even for the testing, because the testing is also tested. The test cases are also tested. Then we have a test plan. So we make a strategy for the whole organization, and there is a test plan for a project. It defines the strategy which will be applied to test an application, the resources that will be used, the environment in which the testing will be done or performed, and the scheduling, that is who will do, what will be done, what specific things are there, the resources, the environment, all these are there in the test plan. The test cases. So test cases are the final, test strategy, then test plan, then test cases. So the test cases, you can say these are the steps and conditions used at the time of testing. So here we want to check all the requirement specification, all the use cases, or you can say all the functionalities, that whether the software is working fine or not. So this can be various type of test cases. We have logical, functional, error, negative, positive, physical, UI, and functional and non-functional test cases. So we have boundary value analysis, we have multiple things, black box, test, white box, various. Then we have the traceability matrix. Now everything is done to make a project successful. It is coming from the requirement. So the requirement give rise to the design details, and then the coding and the testing. So the testing, why it is done, coding, why it is done, design and why it is done, it has to be traced back to certain requirement. The traceability matrix is table that traces and maps the user requirement with the test cases. So the main aim of requirement traceability matrix is to see that all test cases are covered so that no functionality missed during the software testing. All the requirements, all the design, all the coding is properly tested, and this we can trace back to all the requirements. So there are RTM, the very important you can say document. Then the test scenario. This is a collection of set of test cases. We can have multiple test cases. So these test cases which are going to help the testing team to determine the positive and negative aspects of the project. Okay. So as I said, there can be multiple kind of testing. So this test scenario is sometimes also is the document which we refer in SQA. What do you mean by build and release in the context of quality assurance? Differentiate between them. So code, you write a code. Then if you are using in say Visual Studio or any kind of IDE, you build it. So this build you have made, it has not been tested, and then you release it. When you release it, that means it has been tested and now you release it. Builds can be multiple. So build is a software or an application that is ready to be tested. Developers, they create software, that is they make the build and they hand it over to the tester to be tested. So this is a broad phrase that refers to any application that will be examined. The developers can either create a complete program or they can just add a new feature to an existing one and they can make a build. Then that program together with the new functionality is called as a build and it is put through its test by testers. Now what is release? After development and testing, the release is finalized application. The testing team verifies the program and releases it to the final customer end user after testing it. Okay, it's possible that a single release will have multiple builds. So as a result, it is the program that is supplied to the customer end user when the development and testing phases are complete. So the release is based on builds, and there can be multiple builds, but there cannot be multiple releases. Release can only be when one certain release or the delivery is planned. Let us see one by one also. Build is a version of the software or application which the development team hands over to the testing team. So build, whatever you make in your IDE, you actually make a program and give it to the tester to test. Release is the software which has already been tested and now it is ready to be handed over to the end consumers. The build version of the software requires testing to be done. So generally the sanity testing is performed on a build version, but there can be multiple testing. This is just an example. Okay. So sanity testing is, if you know the smoke testing, it is general health checkup. Sanity is proper organ checkup. So whatever has been changed or any functionality has been added, that is properly checked in this. This is a kind of build, that is, it is built over some pre-made build. Release is release version of the software. They don't require any testing. Build version of a software is made more frequently than the release version. Release version, because it is going to be released to the user of the software, are made less frequently than the build version because this is only delivered to the user and it cannot be made every day. You cannot deliver software every day to the user. What do you understand by bug leakage and bug release? Bug is a problem. Bug, the testing is done, the bugs will come. So bug leakage is, what is the difference? When the bug is discovered by the end user or the stakeholder or the customer, that should have been caught in the earlier builds version of the application, a bug leakage occurs. That is, the bug you haven't found out, the customer has found out. You could have found out, but he has found out. So a bug has leaked from your end to the user end. So bug leaking is referring to a fault that exists during the testing, but it was not being discovered by us or a tester or a software team and is subsequently discovered by the end user. What is bug release? When we release, when a particular version of the software is released to the user with a collection of known bugs and defects, we know these are the bugs and defects in the software. It is referred to as the bug release. So bugs of this type are frequently of low severity or low priority. When the company can afford the existence of a bug in the release software rather than the time cost of repairing in that version, it is just released. So in most of the cases, these bugs are disclosed in the release note. It is properly given. Defect rejection ratio, defect leakage ratio. So defect leakage ratio is number of defects missed or leaked divided by the total number of software into 100. Defect rejection ratio is number of defects which are being rejected divided by the total number of defects raised into 100. Defect rejection ratio. What do you understand about traceability metrics in the context of quality assurance? So you see here traceability metrics. This is just a spreadsheet or a table. So every requirement gathering is followed by requirement analysis, and that corresponds and that results in a work product called software requirement specification. So this is the Bible, you can say, for a software team. All the requirements, whenever we test, because the requirement give rise to design, design give rise to code, code give rise to test. So every test should correspond to certain requirement. And this backtracking is called the traceability. And this can be done using a matrix like this, a row or column, where on the left you can have a requirement, on as a row, and on columns you can have test cases. So this is how you can backtrack and relate. The traceability matrix, you can trace the test cases to the requirement and vice versa. Okay, so this is the traceability matrix in quality assurance. So let me tell you again. Traceability matrix is a document. Normally it is a part of a certain document like the SRS also, or later part, the testing document. It is a documented that connects two baseline documents that require many-to-many link to ensure that the relationship is complete. It is used to keep track of requirements and making sure that they are being met on the present project. Okay, so there are three major components of traceability matrix, because every time you are making a design or the code, as I said, the testing code, the code and design should correspond to the SRS. So first one is the forward traceability. Second one is backward or reverse traceability. The third one is bidirectional traceability. So forward traceability, this matrix is used to determine whether the project is progressing in the appropriate direction and for the correct product. So this ensures that each specification is applied to the product and each specification is adequately tested. So it connects test cases to the requirements, which you see in this diagram also. This is kind of forward traceability. And there can be the backward or reverse traceability also. So now it is used to verify that the present product is still on track. The goal of this form of traceability, backward or reverse traceability, is to ensure that we are not expanding the project scope by adding code, design feature, testing or other activities not stated in the requirement. So it also connects the requirement to the test cases. Previously, forward, test cases to requirement. Backward is connecting requirements to test cases. I hope you got the difference. Now, bidirectional traceability, this matrix ensures that all criteria are covered by test cases in both direction, forward and backward. So combine both forward and backward, you get the bidirectional traceability. It examines the impact of change in requirement caused by the defect, etc. What do you understand about defect leakage ratio in the context of quality assurance? So first of all, what is defect leakage? We have bug release also. Defect leakage ratio or defect leakage is what bug we have leaked, we have not found out, and it has gone to the end customer. So software tester utilized this defect leakage as a metric to determine the effectiveness of quality assurance testing. So this is the ratio of total number of flaws or problem attributed to a stage which are captured in subsequent stages to the sum of the total number of defects captured in that stage and the total number of defects assigned to a stage which are captured in the subsequent stage. So defect leakage is a metric that counts the percentage of faults that leak from one testing stage to the next. For example, 10 are there, 8 you have found out, 2 goes, 2 you have leaked. So how much you find out? 2 by 10 into 100. Okay, so the testing team's worth on the other hand is only confirmed when the defect leaking is small or non-existent or zero. Differentiate between quality assurance and quality control. So this we'll see in the next discussion. Thank you so much.